Hello, ma'am.
Good evening, sir.
Good evening, ma'am.
Yes, sir, you can start.
Yes, ma'am. Yes.
Good evening, sir.
Good evening. I think we are done with the chapter carboxylic acid, aldehydes, and ketones. We were supposed to start with a new chapter. Today we'll start with a new chapter. This is amines. This chapter is amines. It's a small chapter for your second PUC. If you can concentrate on these small chapters, amines, biomolecules, and polymers, you should be in a position to get 15 marks in organic chemistry. So organic chemistry in part D, you will be getting for 15 marks. So these three small chapters, if you can concentrate, you will be in a position to score all the all 15 marks. Now, aliphatic and aromatic amines, or this chapter is also called as organic compound. Organic compound containing nitrogen. So organic compound containing nitrogen are generally called as amines. So we have aliphatic amines as well as aromatic amines. We know that aliphatic amines, they are open chain, straight chain. Aromatic amines, they will have a benzene ring. They will have smell, aroma. Now, amines are, how do we define an amine firstly? So amines can be defined as a derivative of ammonia. What do you mean by that derivative of ammonia? We know that ammonia, the molecular formula of ammonia is NH, H, and H. So from this, if these hydrogen atoms are replaced by R, then we call it as derivatives of ammonia. So the parent molecule for amine is ammonia. So from ammonia, we can derive aromatic or aliphatic amines. Now, if from ammonia, if one of the hydrogen atom is replaced, this is parent molecule, this is ammonia. If one of the hydrogen atom is replaced, and in place of that hydrogen, if a R group is added, we have RNH2. This RNH2, this NH2 group is called as amino group. And this is an example for primary amine because this nitrogen is bonded to only one carbon. Since nitrogen is bonded to only one carbon, it's called as primary nitrogen. Now, again, if one of the hydrogen atom from primary amine is replaced by an R group, we get RNHR. Or we can write this as R2NH. This R2NH group is called as imino group. Since this nitrogen is bonded to two carbon atom, it will be called as a secondary amine. And if this hydrogen atom is also replaced by an R group, so we get R3N. This R3N is called as a tertiary amine. Tertiary amine. This tertiary amine is called as nitrile group. It's called as what? Nitrile group. So amines are defined as they are derivatives of ammonia in which one or more hydrogen atoms are replaced by alkyl group or aryl group, benzene ring. Amines are classified into primary, secondary, and tertiary depending on the number of alkyl groups attached to it. So if only one alkyl group is attached, it's called as primary. If two alkyl groups are attached, it's secondary. And if all the three hydrogen atoms are replaced by alkyl groups, then we call it as tertiary tertiary amines. This general formula of primary, secondary amine. The general formula of primary amine is CnH2n plus 1 NH2. This is better and simple to remember. CnH2n plus 2. This is a general formula of an alkene. So from an alkene, one of the hydrogens is replaced by NH2. So we get CnH2n plus 1 NH2. This is the general representation of primary amine. Similarly, the general representation of secondary amine is CnH2n plus 1 twice NH and CnH2n plus 1 thrice N. This will be the general formula of tertiary amine. So I hope that you're understanding what I'm telling. Are you there? Are you there? Now, structure. Nitrogen atom is sp3 hybridized and it has a lone pair of electron. So the shape of the molecule is pyramidal. So generally, primary amines or any nitrogen containing compound, a nitrogen atom will have a lone pair of electron. So whenever the hybridization is sp3, we expect the structure of the molecule to be tetrahedral, but due to lone pair, bond pair repulsion, bond pair, lone pair repulsion, BSCPR theory, the structure of the amines will be of the pyramidal shape, not tetrahedral. Isomerism in amines. Amine shows chain, position, and functional isomerism, and also it shows metamerism. So amines shows chain, position, functional, as well as metamerism. We will learn the questions a little later in the next, after completing the theory part of it. Now, general methods of preparation of amines. What are the general methods of preparation of amines? Now, the first one is ammonolysis. How do we can prepare it from ammonolysis, a reaction of alcohol and alkyl halides. This reaction is called as ammonolysis. This ammonolysis reaction is also called as Hoffman's ammonolysis, or this is also called as Hoffman's alkylation. So preparation of amines from alkyl halides and alcohol, and under that the A is ammonolysis of alkyl halides, and this is also called as Hoffman's ammonolysis, or it is also called as Hoffman's alkylation. Now, what is this Hoffman's alkylation? Now, I will teach you the Hoffman's alkylation here. I needed space, so I will teach here. Now, when ammonia and alkyl halides are heated in a sealed glass tube at 100 degrees Celsius, the statement is like this: when ammonia and alkyl halide are heated in a sealed glass tube, at 100 degrees Celsius, a mixture of primary, secondary, tertiary, and quaternary ammonium salts are obtained. Quaternary ammonium salts are obtained. So this is the statement for ammonolysis, or it's also called as Hoffman's alkylation. So when ammonia and alkyl halide are heated in a sealed glass tube at 100 degrees Celsius, a mixture of primary, secondary, tertiary, and quaternary ammonium salts are obtained. So this is also a test to differentiate between primary, secondary, and tertiary amines. This is also a test to differentiate between primary, secondary, and tertiary amines. Now, an alkyl halide, ammonia we can write like this. First, we'll write alkyl halide, Rx. General representation of an alkyl halide is Rx. And we will write ammonia, NH3, like this. And this is heated at 100 degrees Celsius in a sealed glass tube. So what happens is this hydrogen and X gets eliminated as HX. Now, in this place of X, this NH2 goes. So we have R, N, H, and H. This is an example for a primary amine. This is a general formula of a primary amine, RNH2. Are you there?
Yes, sir.
Yeah. The second step is this primary. See, when this hydrogen can be replaced, these hydrogen also can be replaced. That is what the indication. The second step is this primary amine. We'll write Rx like this alkyl halide. This primary amine I write like this N, H, H, and R. This is primary amine. So what happens is, now again, this H and X gets eliminated as HX. So what's that we get? We get R, we have N, you have H, and you have R. This is secondary amine. Now this hydrogen also can be replaced. So we will write the third step. We can write Rx, alkyl halide, plus I write this as H, N, R, and R. So what happened? This H and X gets eliminated as HX. And what's that we get? We get R, N, R, and R. And this is tertiary amine. Now, what happens is the fourth step. This Rx, and it will react with tertiary amine like this. Now, what happens? Due to inductive effect, the electron pair will move towards the halogen. Halogen will gain negative charge, carbon will gain positive charge. So what happens? We know that on nitrogen, we have a lone pair of electron. So this molecule will undergo heterolytic cleavage. When we say this molecule will undergo heterolytic cleavage, the bond will break here. Now both the electron pair is donated to R. When both the electron pair is donated to R, what happens? We get N, R, R, this is R, and you have a coordinate bond. See, to form a bond, both electrons are given by nitrogen, therefore a coordinate bond. That's why we are represented by an aromatic. And this R contains a positive sign, therefore this gets a positive sign. And halogen is negative, so X minus. So this is called as quaternary ammonium salt. This is called as quaternary ammonium salt. This quaternary ammonium salt, if you observe, this quaternary ammonium salt has three types of bonds. Now, what are those? This R and N, this R and N, and this R and N covalent bond. This R and N is coordinate bond. And this is positive and negative. So we have ionic bond. So this quaternary ammonium salt has covalent bond, coordinate bond, as well as ionic bond. So this is called as Hoffman's alkylation, or it is also called as ammonolysis, or it is also called as aminolysis, AMINOLYSIS. Now, what's the statement? When ammonia and alkyl halide are heated in a sealed glass tube at 100 degrees, a mixture of primary, secondary, tertiary, and quaternary ammonium salt. Now, I made a statement. This reaction is used to differentiate between primary, secondary, and tertiary amine. This is one of the methods to differentiate primary, secondary, and tertiary amine. How do we differentiate primary, secondary, and tertiary amine? Now, if you observe, if you start with the primary amine, this is primary amine. If you start with primary amine, for the complete reaction to take place, it requires 3 moles of alkyl halide. So primary amines will consume 3 moles of alkyl halides. Now, if the reaction is started from secondary amine, for the quaternary salt to form, it will consume 2 moles. Secondary amines will consume 2 moles of alkyl halides. If you start from tertiary amine will react only 1 mole of alkyl halide. So depending on the number of moles of alkyl halide consumed, we can classify or we can differentiate whether the amines is primary, secondary, or tertiary. So primary amines will consume 3 moles of alkyl halides. Secondary amines will consume 2 moles, and tertiary amines will consume 1 mole of alkyl halide. Depending on the number of moles of alkyl halide consumed, we can differentiate primary, secondary, tertiary alkyl halides. This is the first method of preparing amines. I hope you followed this reaction.
Yes, sir.
Now, see, this question can be asked like this. They can ask you what is ammonolysis for 3 marks, or they can ask you, how do you differentiate primary, secondary, and tertiary amine based on ammonolysis? So you should be in a position to write the 4 reactions. I gave you the general reaction. In place of R, you can take CH3, and you can try it at home and try to name the compounds also. Naming, I am not teaching in purpose because I want you to learn, and I will ask you tomorrow naming. I'll give you some examples and you will be naming it. The next one is the second method of preparing is from nitro compound. Second method of preparing is from nitro compound. Nitro compounds. So nitro compounds on reduction with tin in concentrated HCl or tin or lithium aluminum hydride, we get amines. Now, for an example, we will write a statement a little later. We will take an aliphatic amine, CH3, CH2, and NO2. This is nitroethane. This is nitroethane. This is a nitro compound. Now, this nitro compound, when you heat it with a reducing agent, like maybe we can write a strong reducing agent like lithium aluminum hydride. Lithium aluminum hydride. This lithium aluminum hydride is a strong reducing agent, so it gives 6 nascent hydrogen. Now, I'll write 4 nascent hydrogen like this and 2 nascent hydrogen like this. So what happens? Since I have 2 oxygen atom, this 2 oxygen atom will react with 4 hydrogen to form 2 H2O. And in place of this 2 oxygen, what happens? 2 hydrogen goes. So what's the product you get? You get CH3, CH2, and you get NH2. So this is nothing but primary amine. So it will be called as aminoethane. The name of this molecule will be aminoethane. Now, the same reaction if we perform for an aromatic hydrocarbon. So if you take nitrobenzene, like this is nitrobenzene. This nitrobenzene, when it is heated with tin in concentrated HCl, SN is tin in concentrated HCl, this also gives 6 moles of nascent hydrogen. So we can write 4 hydrogen and 2 hydrogen for our understanding. What happens? 4 hydrogen and 2 oxygen gets eliminated as 2 H2O. In place of this 2 oxygen, you get 2H. So therefore, you get a benzene ring and you get NH2. This is a primary amine. Both are primary amines only, what we have learned. And this name is commercially called as aniline. It is commercially called as aniline. So we can prepare primary amines by reduction of nitro compounds. So nitro compounds on reduction gives primary amines. These reactions they can ask you, explain the reduction of nitro compounds or how primary amines are prepared from nitro compounds. So the next question is very important. What we are learning is very important in this chapter. It is a named reaction. So 4 named reaction minimum in organic chemistry is expected to be asked. So under that, this one possibility from amines. In amines, 2 named reactions are there. So one is the preparation, the other one is the chemical property. Now here, this is called as Gabriel thalamide synthesis. Thalamide synthesis. So this Gabriel thalamide synthesis is also a method of preparing primary amine. So it is a very lengthy reaction. You should understand this lengthy reaction. So this is benzene. This is benzene. This is benzoic acid. This is called as phthalic acid. PTHALIC. This is called as phthalic acid. Now, in this phthalic acid, if these OH groups are replaced by, if this OH group and this OH group are replaced by NH, then we get thalamide. Then we get thalamide. So we will write this reaction like this. So the C double bond O we can write here. Here also C double bond O we can write here. And these two are bonded to NH. This is called as thalamide. So the starting reactant for the Gabriel thalamide synthesis is thalamide. So how do we write thalamide? It is a benzene ring. You have C double bond O, you have C double bond O, and you have NH. This is called as thalamide, PTHALIMID, thalamide. Please understand this reaction, it's important. This thalamide, when it's allowed to react with alcoholic potash, potassium hydroxide in alcohol. So what happens is, now you can observe this. This is for only our understanding we write, right? So this OH and this H gets eliminated as water. In place of H, K goes. So you get potassium thalamide. You get a benzene ring, C double bond O, C double bond O, and you have nitrogen, that is N minus, and you will have K plus. So NK, this is called as potassium thalamide. This is the first step of the reaction. So thalamide, when it's allowed to react with alcoholic potassium hydroxide, you get potassium thalamide. This potassium thalamide, when it's allowed to react with an alkyl halide. Now for an example, CH3Br. CH3Br, methyl bromide. So when this is allowed to react with methyl bromide, what happens is this potassium and bromine gets eliminated as KBr. In place of K, the CH3 goes. So when we say, I'll continue the reaction from here. Maybe, all right, here only we will write. So you get a benzene ring. You have C double bond O. You have C double bond O. You have N, and you have CH3. So this is alkyl thalamide. So it will be called as methyl thalamide. This methyl thalamide, when you heat it with sodium hydroxide, So what happens is the bonds break here. Carbon and nitrogen, the bonds break. Now, the sodium hydroxide also, we will try to write it like this, ONA and H. So if I take 2 moles of sodium hydroxide, so 2 hydrogen atoms are there. Those 2 hydrogen atoms reacts with nitrogen. When they react with nitrogen, what is that we get? We get CH3 and NH2. It is what amine? Primary amine. This is the product. What is the byproduct? Now to this carbon, ONA attacks, and to this carbon, ONA attacks. So what's that you get? You get a benzene ring. You have C double bond O, ONA, and you get C double bond O, ONA. So this method is called as Gabriel thalamide synthesis. So I hope that you understood the reaction. So aliphatic primary amines can be prepared, conveniently prepared by Gabriel thalamide synthesis, starting from thalamide, PTHALIMID. The sequence of the reaction is this. Thalamide, when it's allowed to react with alcoholic potassium hydroxide, water gets eliminated, forming potassium thalamide. Because this H and this OH gets eliminated, in place of H, K goes. Therefore, you get potassium thalamide. This potassium thalamide, if you allow it to react with alkyl halide, here we have taken methyl bromide. This K and Br gets eliminated as KBr. In place of K, the CH3 goes. Therefore, you get a benzene ring, C double bond O, C double bond O, N, and you get CH3. This, when you treat it with sodium hydroxide, 2 moles, this 2 hydrogen reacts with nitrogen, you get CH3NH2. In place of this carbon, you get ONA, and in place of this nitrogen, you get ONA. Here also the bond breaks and ONA gets bonded to this carbon. Therefore, you get sodium salt of this acid. This is called as sodium phthalate. So this is the third method and important method of preparation of primary aliphatic halides. This is a named reaction, so they will ask you for the preparation of primary amines. 1 minute. Now, continuation. The next method of preparation is from alkane nitrile. I'll erase this and we will. Did you understand this, Gabriel Thalamide?
Yes, sir.
Yeah. Now, the next method of preparation is from alkane nitriles. Nitriles are called as cyanides. So, otherwise, we can say cyanides are also called as nitriles. So it is from alkane and nitriles. So how do you prepare a primary amine from alkane and nitrile? A simple example we will take. We will take methyl nitrile, CH3 C triple bond N. This is called as methyl nitrile. This methyl nitrile, on heating it with hydrogen gas in the presence of nickel catalyst at 400 Kelvin, around 180 degrees Celsius or something. So what happens? 2 moles of nitrogen we've taken. 1 mole of nitrogen attacks carbon. The second mole of nitrogen attacks nitrogen. So what happened? 2 pi bonds will break. So when 2 pi bonds break, we have CH3, CH2, single bond NH2. This is nothing but a primary amine. It's called as ethyl amine. So this is from alkane nitrile. So nitriles are nothing but cyanides. So alkane and nitrile on reduction with hydrogen in the presence of nickel catalyst or lithium aluminum hydride at 400 Kelvin, we get a primary amine. The next one is the fifth method is reduction of amides. Reduction of amides. So amides are represented as RC double bond O NH2. C double bond O NH2 is called as amides. These amides on reduction with lithium aluminum hydride. This amides on reduction with lithium aluminum hydride. Lithium aluminum hydride is a strong reducing agent. We can write it as 2H and 2H. So what happens is this 2 hydrogen and oxygen gets eliminated as water. In place of oxygen, you get 2 hydrogen. Therefore, you get RCH2 and NH2. This is also an example for primary amine. So amides on reduction with lithium aluminum hydride, the product what we get is also a primary amine. So the next named reaction I was telling, an important named reaction. One, we learned Gabriel Thalamide method. The second one is called as Hoffman's bromide reaction. This Hoffman's bromide reaction is also a very important named reaction. So you can expect any one of the question, either Gabriel Thalamide or Hoffman's bromide method. It's called as Hoffman's brom, B-R-O-M, amide, bromamide method, or it is also called as Hoffman's degradation reaction. Hoffman's degradation reaction. Now, what is this Hoffman's degradation reaction? When an amide is heated or refluxed with bromine and potassium hydroxide solution, when amide is refluxed, heated for a long time, refluxed with bromine and potassium hydroxide solution, primary amines are formed. Primary amines are formed. So the example we will take is simple example, amide CH3CONH2. Or we will write this for our understanding like this: CH3, C double bond O, and NH2. It is an amide. This is called as acetamide. This acetamide, when you react or when you heat it with bromine and potassium hydroxide, see the stoichiometry here: 1 mole of amide, 1 mole of bromine, and 4 moles of potassium hydroxide. Since 4 moles of potassium hydroxide we have taken, I can say 2 potassium reacts with bromine to form 2 KBr as a byproduct. 4 potassium is there, 2 will react with bromine and gets eliminated as 2 KBr. Plus, we have another 2 potassium, so I'll write it as K2. And this carbon, CO, one minute, my writing. So this another 2 potassium will react with the CO, and you can see 4 oxygen atoms are there here. In that 4, 2 will react with this. Totally you get K2CO3. And what else is left out? Here 2 more oxygen is there, 4 hydrogen is there. So 2 moles of water gets eliminated as a product, byproduct. What else is left out? You have CH3 and you have NH2. This is primary amide. This is called as Hoffman's bromide reaction. So when an amide is refluxed, heated with bromine and potassium hydroxide, so primary amides are obtained. Now this is an aliphatic amide. The same reaction we can perform with aromatic amides also. So if you take a benzamide, like this, C6H5, C double bond O, NH2. So what happens if you heat it with bromine and potassium hydroxide? You get potassium bromide, potassium carbonate, water, and you get aniline. C6H5, NH2, aminobenzene, or you get an aromatic amine called as aniline. So these are the methods which is prescribed for the preparation of amines in your textbooks or in your syllabus. Now we have to learn the properties of amines. We will learn the properties of amines in a few minutes' time. So Gabriel Thalamide method, hydrolysis, amide, I have taught you all these methods. Yes, we have learned. And Curtis method is not there in the syllabus. We are not learning. Smith method is also not there. Lawson's rearrangement is also not there. We will have to learn with the chemical properties of amines. Now we will learn the chemical properties of amines now. I'll erase this. Did you understand Hoffman's bromide method?
Yes, sir.
Yeah. See, Gabriel Thalamide method and Hoffman's bromide method give more importance, as well as reduction. I told you, nitroalkanes or nitro compounds can be reduced to form primary amines. Those 3 reactions so far what you have learned, you can expect 1 question. Now, coming to chemical properties, the first property is the basic character. Amines are basic in nature. Why amines are basic in nature? What is the reason for amines to be basic in nature? Now, for an example, as we were learning, any nitrogen containing compound or nitrogen will have a lone pair of electrons. Now, when amines are allowed to react with hydrogen acids, hydrochloric acid or hydrobromic acid, what happens? Hydrogen will have a positive character and halogen will have a negative character. So a pair of electrons will be donated to hydrogen. Therefore, we get R NH3 plus, and you will get NX minus. It is a salt. So now we know that HX is an acid and the product is a salt. It means this should possess basic character. So amines are basic because it reacts with hydrogen acids to form a salt. Now you should know that lone pair of electron donors are called as Lewis base. So amines are generally called as Lewis base because it can donate a pair of electron. Lone pair of electron donors are called as Lewis base. Now I taught you ammonolysis, and I told you ammonolysis is a test to differentiate between primary, secondary amine. I wrote a general reaction there. I want you to take in place of R CH3 and write the reaction, because tomorrow I'm going to ask you the names of the molecules. All right. So kindly try doing it. We will learn. Now coming to the next reaction, that is reaction with nitrous acid. So ammonolysis comes the chemical property as well as what? The preparation method. All right. So that's why I asked you this question here. Now, reaction with nitrous acid. So nitrous acid is also one of the tests to differentiate between primary, secondary, and tertiary amines. Now, nitrous acid is an unstable acid. So it cannot be prepared and stored in the containers. So whenever it is required, it can be prepared by the reaction of sodium nitrite with HCl. The sodium nitrite reacts with HCl to form HNO2 plus NaCl. So this HNO2 is called as nitrous acid. So when primary amine, for an example, if I take methyl amine, is allowed to react with nitrous acid, HNO2. This HNO2, I will write like this, O double bond N OH, HNO2. So what happens is H2 and O gets eliminated as H2. These two nitrogen atoms will combine and gets eliminated as nitrogen gas. What else is left out? You have CH3 and you have OH. So we get primary alcohol. So primary amine, where it's allowed to react with nitrous acid. This is nitrous acid. So we get primary alcohol. And they can ask you for 1 mark. Name the gas liberated when nitrous acid is allowed to react with primary amines. So the gas liberated is nitrogen. Now, 2 or 3 more reactions we will learn, important reactions. So I hope you understood with nitrous acid. Now, this is an aromatic aliphatic compound. If the same reaction when we perform with an aromatic compound, what happens? Now, this reaction is this. Aniline. Aniline is also a primary amine. This aniline is a aromatic primary amine. This aniline, when it's allowed to react with nitrous acid will write like this, O double bond N OH. And we also have HCl here. I will write HCl at 0 degrees Celsius, 0 to 5 degrees Celsius in specific. So what happened? H2 and O gets eliminated. Here also O and H gets eliminated as 2 moles of water. And what else we have? We have a benzene ring. We have nitrogen here. We have a double bond nitrogen here. And you have Cl. This is called as a dye. It is called as benzene diazonium chloride. This benzene diazonium chloride is called as BDC, abbreviated as BDC. It's a red colored dye. It's a red colored dye. It's a coloring agent. Red colored dye. So aliphatic amines does not give dyes, but the aromatic amines like aniline reacts with nitrous acid in the presence of HCl at around 0 to 5 degrees Celsius to form a red colored dye, and it's called as benzene diazonium chloride. This reaction is called as diazotization reaction. diazotide. Di stands for 2, azo stands for nitrogen. This molecule contains 2 nitrogen, therefore it's called as diazotization reaction. So they can ask you the reaction of nitrous acid with aliphatic amine and aromatic amine. With aromatic amines, it is called as a diformation, diazotization reaction. Next is another named reaction, is called as carbyl amine reaction. Carbyl amine reaction. What is this carbyl amine reaction? It's a reaction of aliphatic or aromatic primary amine. Aliphatic or aromatic primary amines with chloroform and alcoholic potash. Potassium hydroxide is called as potash. Is called as carbyl amine. Isocyanates are formed. Isocyanates are formed. It is also an important reaction. Carbyl amine reaction. Aliphatic amine or aromatic amine, primary amine, when heated with chloroform and alcoholic potash, we get isocyanates. Now for an example, if we take an aliphatic amine like this, CH3, CH2, NH2, this is allowed to react with chloroform. Chloroform is CHCl3. Chloroform is CHCl3 in the presence of alcoholic potassium hydroxide. Alcoholic potassium hydroxide, we are heating. So we'll take 3 moles of this. Now this 3 chlorine and 3K gets eliminated as 3KCl. Now this 2 hydrogen, this 1 hydrogen, and you have 3 OH groups here. So this 2 plus 1, 3 hydrogen and 3 OH groups gets eliminated as 3H2O. What else is left out? You have CH3, CH2, single bond N, and you have the C. So you will have a triple bond. So it is NC. NC are called as isocyanates. So here the name of this molecule will be called as ethyl isocyanate. So this ethyl isocyanates are generally called as carbyl amine. It is a highly toxic gas. It is highly dangerous. So carbyl amines are nothing but isocyanates, which are highly toxic in nature. The next reaction tomorrow we will learn some other chemical properties. So last reaction we'll learn today and then we'll stop. So did you understand this reaction, carbyl amine reaction?
Yes, sir.
Yeah. The next reaction is so many more reactions are there. We will learn the reaction that's called as acylation reaction. So acylation is reaction with acid chlorides. So primary and secondary amines react with acid chlorides. Acid chlorides will form substituted acyl derivatives. To form substituted acyl derivatives. Now, a simple example, methylamine, CH3NH2. This methylamine, when allowed to react with acetyl, one of the hydrogen and the Cl gets eliminated as HCl. So we have CH3, NH here, and you have COCl, COCH3. So this is called as, you write the name of IUPAC also, you try to learn. Otherwise, I'll teach you tomorrow. So the same thing, acylation, we can also perform with an aromatic amine, primary amine. This aromatic primary amine, we will take aniline here. This aniline where it's allowed to react with acetyl chloride, CH3COCl, in the presence of a base like pyridine. What happened? This H and Cl gets eliminated as HCl. In place of it, the CO group. So there you get a benzene ring, you have NH, you have CO, CH3. So this is also an amide. It's also an amide. Here also we get an amide. We will learn the names of this amide a little later. This is otherwise called as Schotten-Baumann reaction. Now, Schotten-Baumann reaction, instead of using acetyl chloride, we can use benzoyl chloride. What is the benzoyl chloride? Now, instead of the CH3, if we use C6H5, COCl, it's called as benzoyl chloride. So here you will get C6H5. So H and Cl gets eliminated. In place of H, C6H5 goes. This is C6H5. This named reaction is called as Schotten-Baumann reaction. It's called as Schotten-Baumann reaction. Schotten, Schotten-Baumann reaction. BAUMAN, Schotten-Baumann reaction.
So
Any
screen is not visible, sir.
screen is not visible? All right,
No,
1 minute.
sir.
All right, 1 minute. I don't know what happened. Yeah. Okay. Now it's visible. Okay.
Yes, sir.
Now this is simple, as like the same reaction. So instead of CH3COCl, we have taken C6H5COCl. The C6H5COCl is called as benzoyl chloride. It is also an example for acid chloride. This is acetyl chloride, and here it is benzoyl chloride. And this also happens in the presence of base. So what happens? H and Cl gets eliminated as HCl. In place of this H, COC6H5 gets bonded. So names we will learn tomorrow. And this is called as a Schotten-Baumann reaction. So we'll have to learn some more reactions tomorrow. Tomorrow we'll finish with the chapter amines, along with the MCQs, possibly. I think we should finish. So if we finish organic chemistry, is almost done. We have biochemistry part, biomolecules, polymers, chemistry, all that we will learn tomorrow. So this is also a little big chapter. We will see whether we can finish it tomorrow. All right, we will stop the class today. Ma'am, I'll stop the class, ma'am. Ma'am?
Thank you, sir.
Thank you, sir.
Still now what you've done? Any clarifications so far?